Hi everybody, welcome to section 6.3, solving systems of equations using elimination. Not sure what I was thinking there. So we have so far solved systems of equations by graphing, solving systems of equations using substitution. Now we're going to use elimination. We've actually got two different sections on this. So everybody knows, hopefully by now, two or more equations, two or more variables is what a system is. So elimination is another method to find the solution to a system. Remember, a solution to a system is an XY ordered pair. And what we're going to do is we're going to eliminate one variable by adding the equations together. And I already said this, but your answer is an ordered pair, X and Y. So let's talk about the steps for elimination. First thing, make sure that your variables, your equal sign, and your constant, the number, are all lined up. Typically, we like it to be in standard form. Think back to our graphing linear equations, standard form, ax plus by equals c. Everything should be nice and neat and lined up. All of our x's, all of our y's, all of our equal signs. Look for common coefficients. A coefficient is the number that's out in front of a variable. We want them to be common or the same. You're going to make sure that the common coefficients have opposite signs. If they do not have opposite signs, you may need to multiply everything in that equation by a -1. If they have the opposite signs already, you're ready to go. Add the equations. You will lose or eliminate one variable. That's why it's called elimination. It goes away completely. You'll go ahead and solve a pretty easy equation to finish off and then use substitution to find the other variable because remember, your answer is an ordered pair x comma y. Right? So it's all about lining everything up and looking at those coefficients, those numbers out in front of the variables. So let's start with this one. Use elimination to solve the system of equations. So when I look at my coefficients of my x terms, does everybody see a 3 and a 2? So the coefficient is the number that's out in front. Do those two numbers match? Obviously not. Look at your coefficients of your y's. What do we have for coefficients of y terms? A 5 and a 5. Matching coefficients. Do those coefficients have opposite signs? Plus and a minus, right? So we've got opposite signs. So what we're going to do is we are going to add the equations straight up and down. So if I go 2x plus 3x, I get 5x. If I add straight up and down -5y plus 5y, I don't have any y's left. Those variables got eliminated. I'm going to bring my equal sign straight down and I'm going to add -16 plus 31. That's a 15. Now we've got a pretty easy equation to solve to finish this problem. If I gave the equation 5x equals 15, everybody would know to divide by 5, right? So x must be equal to 3. My solution is going to be 3 something. I'm not done because I still need to know what y equals. So I'm going to substitute to find the value of the other variable. I can go to either equation. Go to the one that looks easiest. I try to avoid negatives. So I'm going to use this one right here. 2x plus 5y equals 31. Sometimes people avoid large numbers. We found that x was 3. So 2 times 3 is 6, plus 5y equals 31. We just have to solve this equation the old-fashioned way. I'm going to subtract 6 from both sides. This might be a really great time to hit pause, do this problem yourself, and see if you get the same value for y. I got a y equals 5. So my solution is 3, 5. I could go back and check this. There's always a built-in double check. I could put a 3 in for the x, so 5 in for the y, and see if I get the right answer when I do the math for both of the equations. All right, let's do one more. Let's do number 2. 2x plus 5y equals 6 and 2x plus 9y equals 22. Which variable has common coefficients? The x, right? Those both are 2's. Do those common coefficients have do the common coefficients have opposite signs? Those are both positive 2's. So I may need to multiply by a -1. Well, I can do that. If I multiply this whole top equation by -1, I would end up with a -2x, a -9y, and a -22. If you want to rewrite it, the top equation would not change at all. The bottom equation, I'm going to erase these out of here and then rewrite it. The bottom equation, every sign would change. So -2x minus 9y. The most common mistake people make are they forget to multiply the 22 by the -1 as well. Once I've got that, those x's both have 2's in front of them. They are one positive, one negative, so I can add right straight up and down. 2x minus 2x is eliminated. 5y minus 9y is -4y. 6 plus a -22 is a -16. I'm going to go ahead and divide both sides by -4. So I know that y is equal to 4. So I know in my final answer, my answer for my system is going to be something 4, but of course I have to go back and figure out what the x value is. I know it's the y value because it says y is equal to 4. So I'm going to go back into the top equation. That one seems easier this time. 2x plus 5y equals 6. We just found that the y value was 4. So 2x plus 5 times 4 is 20 equals 6. I'm going to solve this the same way we've been solving equations all year. 2x equals -14. Whoops, divide by 2. That's a positive 2. So x should be equal to -7. And again, I can go back and check that by putting -7, 4 in for the x and the y in both of those equations and make sure I get the right answer. So built-in double check. So my solution to that is -7, 4. I would not want to graph those equations, but if we did graph them, they would intersect at the point -7, 4. So elimination is another algebraic method to solve a system of equations. So I think we're good on examples. We did one example where the signs were already opposite. We did one example where we had to times by -1 to make opposite signs. One example where we found the x first, one example where we found the y first. There's no right or wrong way to start those. So here's what I would like to know from you. Please don't write out the question. Just tell me what's the most important thing to remember when using elimination to solve a system. There's a lot of possibilities. What do you think, like, oh my gosh, I got to remember to do that or to check for those or, you know, go back and find the other variable or look for signs or those kinds of things. And one practice problem, which could possibly be the one we just did. Oh my gosh. Change that. Do practice problem number 3. So do this system of equations instead. 4x plus 2y equals 28. And a 4x minus 3y equals 18. That's practice problem number 3, if I'm remembering right. Yep. So you can do it there, or you can do the problem over here. But you should give me an ordered pair. I noticed that the x's both have the same number out in front, common coefficient, but they are not opposite signs. So we're going to have to multiply one of those equations by a -1. That is it for section 6.3, elimination to solve systems. Come into class with questions. Go back and rewatch if you need to. And we'll see you next time.